fair warning, I have neither practiced nor timed this talk, but I don't think I have that much content, so we shouldn't run over into lunch. But I thought I would start by playing a little game. I don't know if the sound's going to come through, but it doesn't really matter, doesn't it? So I put my name in. I must go. Jumper Workshop 2023 needs me. Does anybody recognize this game? Yeah? One or two? So let's check what's in this first little chest here. Just some money. We're going to go and try to save Zelda. Check the signpost. Well, we'll do that in a bit. We don't need to do that yet. We want to explore a bit more first. So we're trying to find our way into the castle here. We've got a little secret corridor. We meet our uncle in the basement who gives us bow and arrows. Okay, let's use this bow and arrow to get rid of these guys. And what do we have in this chest? It's a pearl! Okay. Let's stop that one. Okay, let's quit that. Okay, there we go. All right, let me get to my other screen with this one. Okay, yeah, so that was Zelda, A Link to the Past. The left is Link, the right is Zelda. People often get confused between the two. And yeah, what is it? I mean, it's a game for the Super Nintendo or the Super Famicom, if you're from America. And it was released in late 1991. So I played it when I was a kid, basically about 30 years ago. And it took me an entire summer to complete the game. Because it's quite hard when you're like 13 years old. And yeah, what do you need to do to complete it? Well, you need to storm the castle to rescue Zelda, as we were kind of starting to do there. Collect 3 pendants, which allows you to get the Master Sword. Link likes to hold things up in the air. That's a common theme in the game as well. And you use that to defeat Aga, who takes you into the Dark World, and then you collect 7 crystals, which frees 7 maidens to allow you to break the seal on Ganon's tower, so you can defeat Ganon and save Hyrule. And it's pretty straightforward, pretty simple. And it's a relatively linear game, and the key is that it opens up by you collect various items as you play the game, and they grant progression through their use, so that it kind of guides you through the game in a sort of linear progression. And you can play it a little bit out of order if you want to, but the path, the route is quite predetermined because the items you get determine the route, essentially. So like a lot of video games, this has become one that gets speedrun, where people basically try and complete the game as quickly as possible. And there's this annual, or now multi-times a year event, charity event, where they play the games quickly. They get lots of people putting money to do that, and that goes to charity, which is quite cool. I think I mentioned this actually last year in a talk. Yeah, so people are speedrunning it. I don't actually find speedrunning very interesting because it kind of becomes a bit of a grind, and it's determined on RNG, random number generation, so a lot of luck involved, especially with this game. The current world record for this game is about 1 hour 22 minutes, and bear in mind it took me an entire summer to complete this when I was a kid. NMG here stands for no major glitches, because there are lots of bugs in the game that allow you to break the game. So you can complete the game in about 2 minutes if you use those glitches, but those are not allowed. Yeah, so this is a charity event where people a few times a year do this. Not just this game, lots of other games. And they live stream and they upload videos to YouTube. And basically, I first encountered a different version of this game in 2018. So I occasionally watch some of these speedruns more out of kind of not quite morbid curiosity, because they will say, is this game completed in a stupidly short amount of time? And it's, how did they do that? So I encountered this game through the algorithm on YouTube, basically about 4 years ago, 5 years ago now. And what is it? Well, it's a randomized version of the game. So it's a patched version of the game where all the items that grant you progression are shuffled. And there are 216 items in the original game. And if you shuffle the items, it changes the route, the possible route through the game, giving you effectively infinite variations. And the randomizer itself understands the logic of the game, so it prevents unbeatable games by putting an object in a place that can't logically be accessed. And it also allows different modes of randomization. So a patched version of the game might end up with a completely different route to what we saw at the start. So you might not have to storm the castle. You don't have to collect 3 pendants. You have to get the Master Sword, but maybe not to defeat Aga. Then you get transported in the Dark World. Maybe have to rescue the 7 maidens. Then climb the tower and defeat Ganon, saving Hyrule. So we can skip lots of parts of the game. So it's far less linear, because we don't have to complete as many tasks that we have to complete. But the randomizer will make them accessible, just that they're not logically required to beat the game. So if you actually get those items, they could send you on a wild goose chase. So how have they done this? And this is what I find super interesting about this game. Essentially, they've taken a 32-year-old ROM dump, disassembled it, and then figured out where all the items are in the original ROM. And they used originally C# to patch this ROM. Now it's in PHP since about 2016, but probably predates that. That's the first commit. It's on version 31 with version 32 in preview. And like I said, it knows the address space of every item in the game, but it also has the code to know the logical requirements to access those items in the game. And at first it was simply randomizing items in the game, but now they randomize lots and lots of things. So they can randomize entrances, they can randomize bosses, pots, enemies, game modes. So this infinite variations it's kind of going that way. It's becoming not quite infinite variations. And to give you one example of a location in the game, this is the checkerboard cave. So what you have to do here is lift this rock up, which allows you to get into that cave to pick up the item. So I think in the vanilla game, this is a heart piece, which gives you more life. In the randomizer, it could be almost anything. But in the vanilla game, it's accessed quite late, because I think it's about 2/3 to 3/4 of the way through the game, because you require so many items to get to this particular place. You have to go here and then go there and then go somewhere else, and then finally you arrive at this place. So you need 4 or 5 items just to get here. But in the randomizer, you could get those items within the first 5 minutes. So suddenly this area is open. And the key in playing the game is knowing that those items grant you the logical access to this location that would normally be accessed quite late in the game. So on the code side of this, what they've done is essentially coded all of the locations in the game with the address space in the ROM, so we can see there's clearly an address space. And they've named it. And we have a location collection item class. And yet, anytime we put something in a location, we're essentially changing what's in the address space in the ROM. So the logical requirements for this address space in the ROM are these. So we have to be able to lift that green rock. We have to have the magic mirror. So the magic mirror allows us to transition between the light world and the dark world. And we have to be able to logically access the region where this item is. And this world get region will also have its own logical requirements. So this is kind of nicely factored in a way that it simplifies this if clause. The world get region Maya can enter will have its own list of requirements. This is a relatively simple if block here. Some of the later locations and more complex locations have longer if blocks. So this is the very last chest in the vanilla game. So in the vanilla game, you need a lot of, you need every single item to be able to get to this location in the vanilla game because it's the very last chest. So you need to have a hook shot and shoot arrows, light torches, blah, 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 blah. But again, in the randomizer, in theory, you could get the items to get here quite early. So what's the attraction of the randomizer? Every new seed, so every time you generate a new game, it's a different game. We have about 20 items required to beat the game and 216 possible locations it can be. We know how to get to those locations. If you played the game when you were younger or you play the game a bit, you quickly learn the requirements to get to these locations. And the idea is to do it as quickly as possible. So, and sometimes we have interesting routing or logic problems. And of course, this is a classic known problem in combinatorial maths or computer science, the traveling salesman, right? The traveling link in this particular case, which is a NP hard routing problem. It's not actually NP complex, which is one of the things I learned. But here it is more complex because certain items are only accessible after getting specific items. And we don't know where those specific items are. So we're adding known unknowns to an NP hard problem. And the route evolves as the items are accessed, including dead ends and backtracking. So as you play the game, you're trying to solve this problem in your head, trying to remember what items you have, what aims you need to get, where they normally are, where they might be given the items you've got. It's kind of interesting. So how does a randomizer actually create the route? It's actually pretty straightforward. Basically what it does is it shuffles all of the locations in the game and then assigns an item to the first location, if that's logically possible. If so, it moves on to the next location and assigns an item to that location, if it's logically possible, given what we've already placed. So this is where a lot of the code is a bit more complex in that it has to then check what have we placed already. Can we get to what we want to place given what we've already placed? And do we have any problems that would make the game unbeatable? What about solving the route? Well, that's the fun. You never know what you're going to get. The aim of the game, the randomizer, is to solve the route. So let's generate a game with debug enabled to show the fill algorithm in action. Let me go up here. I'll see that okay. So let's make it a little bit bigger. So I have a little shell script here that generates the game. It calls the relevant command to generate the game. The randomizer itself takes quite a few options, so we can define certain constraints on how it generates, or how the world state is, or how difficult it is. We can remove some of the items that make the game a bit easier or harder. So if I run this with verbose set, so we saw there the trace of it placing all the items. So if I scroll up to the top, we see the first thing it does is it basically defines which dungeons are required to beat the game. Then it places all of the keys and the compasses. These allow you to, in the vanilla game, these will allow you to solve the dungeons, basically. And then we start placing more dungeon things, compasses, maps, and then we start filling in the items. So we can see here that we start putting in items required to beat the game. So the hammer here is one of the items that is always required to beat the game. So it's put that in this particular location. And then there are some items here that we don't need, but as I said, it's shuffling them, so there's no determined order to what items get placed where until it tries. And after it's done all of that, it generates a game that we can play. So down at the bottom, there should be a ROM that's been generated, which is here. And what I can do is I can drag that. If I select it, not that one, but that one. And it should start up. And this is a slightly different world state. So the one I showed at the start is the default state of the world. This is actually slightly different in that it's open. So we can start from a different place. And basically we've got a different kind of access. And as I said, all the items here are randomized. So we've opened up the world a little bit and we've said where we want all the items to be, at least the randomizer has. And now we've got 3 locations that we maybe or maybe don't have to go to get the items to complete the game. And what's come from this? What's come from the randomizer? Well, there's a big community built around this thing. This is one of, well, you can see I have 4 Discord servers open there. This is the main link to the past randomizer Discord community server. And when I opened this last week, there was almost 7,000 users online. We've got these ROM hacks. So this is a practice hack that allows you to jump to any location to practice if you want to optimize your strategies. People have built these tools to track. So when some people play the game, they have this map tracker open and they keep track of what items they've got, and it helps them a little bit if they're not as familiar with the game. There's this site which allows you to have a friendly race, so you can race against other people, 1 or more people. And then there's tournaments. So every year there's several tournaments where there's prize money up for grabs at the end. Podcasts. So there's a Go Mode podcast, which is now over 100 episodes. And they run their own mentor tournament to mentor people new to the game. And then development communities. So the code is actually on GitHub, so you can fork it and submit patches, things like that. This is somebody changing the logical requirements. So add flute to inverted, light world access logic. And then people stream. Obviously, there's lots of stuff on Twitch. So yeah, what did Zelda teach me about non-deterministic polynomial time complexity? Well, it's fun, and it's an enjoyable way to waste a lot of time. Any questions? Yeah, Rolf.
It's a program which runs on a PC or in the web.
So what platforms do you need to run this program? What I'm running it on here is an emulator for a Super Nintendo. So, and there's lots of those available for various operating systems. I used to actually run it on a little mini Super Nintendo, which I think is basically a Raspberry Pi with an emulator in it. And I would plug it into this and put the games onto it. And it was a bit of a faff, and that's the reason why I haven't given this talk yet. Well, until now, because I finally realized I could put an emulator on this thing, and then it makes it a bit easier.
But there's no JavaScript emulation.
I think somebody has written a Super Nintendo emulator in JavaScript, I believe. I'm not quite sure, but it does ring some bells. Yeah. Daniel.
I'm not a Zelda player myself, as you know. I just want to make sure that I understood it correctly. The original game has some kind of randomization to give you different adventures. And this program that's called Randomizer, it does not only seed the game with some randomness, but it changes part one to make it even more random.
So Dan is asking if the original game had any randomization in it. the answer is no. So the original game is a fixed set of items in a fixed set of places. Completely deterministic. So this changes the game entirely. Yeah. Any more questions? Rolf?
Can you also change that I have to free this other monster?
Yeah. So can you change essentially some of the required goals in the game? Yes, the answer is yes. So they've now randomized it so much that you can generate a game that bypasses a lot of the requirements. The only hard requirement is defeating Ganon, and that can be accessed. It depends because there's so many.
I can't defeat the mains.
You don't have to. No, not in the randomizer. No. Can you kill Zelda? Well, you don't have to rescue her in some of the variations, so I suppose, yeah, logically, yeah. Any more questions? No? Okay, great. Thanks.